Hey everyone, how goes it? And welcome back to Computer Science 552 Game Development. Within our game production process, we're focusing primarily on game development. Within that process, we start looking at the role of the artist creating game assets. We now start discussing assets and how they work with a game engine. As discussed, an asset is an essential resource for a game. These include audio assets, visual assets, story assets, and scripting assets. Game engines provide importers to easily include most forms of assets. Some engines require updating code to include new assets. Other engines allow dragging and dropping resources, and then they are automatically processed. Importers process the asset to work with the game engine. The raw files need to work within the game system, which requires some adjustments. The parameters for the importer can be adjusted to better process the asset. Some of these could be setting the alpha or transparency channel for a 2D image, changing from stereo to mono for an audio asset, or assigning the animation clips to an animated 3D model. Importers can only handle specific file types. Files have a specific format and have to be read, decoded, and processed in different ways. We should be aware of the file types that a game engine supports and details around them. For instance, some common audio assets would have the file format of WAV, MP3, or OGG. Visual asset file format types may be PNG, JPEG, FBX, or OBJ. Similar assets like visual or audio can have many different file types with advantages and disadvantages. Knowing which file type or the kind of file to use is important for development. For instance, with visual 2D assets, you have PNGs. These are image file types that includes an alpha channel for transparencies. JPEGs are image files that do not include transparencies. This may be an important detail when creating sprites. Related to this, visual 3D assets like OBJ are static 3D meshes. However, FBX is a 3D mesh that may include animation. In a similar way, audio assets like WAV are uncompressed audio files. MP3s are compressed audio files, and OGG are a more advanced compressed audio file. Again, being aware of the types and what they provide is necessary to being a good developer. Today, we focus our attention on visual assets. A visual asset is any kind of illustrated element used in a game. Some common visual assets include user interface or UI, backgrounds and skyboxes, sprites, and fonts. Visual design elements are the basic concept which frames its structure and presents a visual message. The visual design elements include a line. This is a visual path that enables the eye to move within a piece. This is not the same as an edge, which is described by other visual design elements. It is more of what is your eye drawn to. The extended idea is what path does your eye follow. Shapes are areas defined by edges within a piece. Geometric versus organic, strong versus weak edges are ways that we define shapes. Colors are hues with various values and intensities. We keep in mind that a hue is a major property of a color, and it is essentially how we perceive the visual color spectrum: red, orange, yellow, green, blue, indigo, and violet. Values and intensities are other important properties of color that can then relate to concepts of saturation and brightness. Textures are the surface qualities which translates into tactile illusions. This can relate to the bumpiness or smoothness of a surface. Form corresponds to the 3D length, width, and depth of an illustrated object. The same object may be illustrated for different perspectives, but will always have the same form. One-point or hallway perspectives are one way that we may implement form. Value is shading amounts which are used to emphasize the form. The difference in value is called contrast. Concepts of highlights, midtones, and shadows are the concepts that are related to values. Space describes the space taken up or in between objects. This is where the ideas of positive and negative space come from. Positive space is taken up by objects of interest. It is a part of the image that the line is drawn to. Negative space is the space in between, the path our eyes follow within the negative space of an image. Basics of visual are rooted in color theory. This is a huge field that has been studied for thousands of years and is rooted in the behavior and impacts of colors. Some of the large concepts in color theory are color mixing, color contrast, color harmony, color schemes, and color symbolism. Color mixing is a large area of study within color theory. It was originally based on how to mix together pigments. Color mixing models are based on the relative brightness of the resulting mixture. Color mixing models include additive, subtractive, and average. The additive combines two or more colors into a new color with its brightness equal to the sum of the component's brightness. The additive model is commonly used in lights or screen displays. The RGB color model is a common additive model which uses red, green, and blue as its primary colors. Hexadecimal values are used to represent each one. As we know, these are based on base 16 values ranging from 0 to F. More often, it is 2 hexadecimal values which form or provide 32 bits worth of color data. The value 00, or just 0, is the absence of color, or black, and FF, or 31, is a color's full intensity. The RGBA color model is the same as RGB, but also adds an alpha or transparency channel. This adds an extra hexadecimal value to represent the A. Just like before, 0 represents an invisible color, and FF is fully opaque. The subtractive color model lowers the brightness of the resulting color below the brightnesses of both combined colors. This is the color model used for describing pigments and printers. This is also the one that were commonly taught in American kindergartens. The RYB color model is a common subtractive model where red, yellow, and blue are the primary colors. We can notice this when we mix together blue and red. We notice in this one, when we mix together blue and red, it creates purple. But if we mix it together in the RGB additive model, it creates magenta. Purple has a lower color brightness value than either the red and the blue. However, magenta will have a higher brightness value than either red or blue. The CMYK color model is another subtractive model where cyan, magenta, yellow, and black are the primary colors. This is frequently used in printmaking. It's very useful to know this in graphics design or when printed materials like packaging need to be considered. Going back to RGB, HSL, hue, saturation, and lightness, is a cylindrical coordinate representation of points in RGB. Hue is the color, or how we perceive a color in relation to the color spectrum: red, orange, yellow, green, blue, indigo, violet. Angle from the center of the circle is what determines the hue. In most cases, the angle of 0 degrees is red, then 120 degrees is green, and finally 240 degrees is blue. Saturation describes the intensity or the colorfulness of a color. Full saturation is equal to full color, so a fully saturated green will be very green. No saturation is gray, so a green with no saturation will just be gray. The gray shade is based on the lightness property. The distance from the radius is how this is measured. Here's a quick nifty tip. Reducing the saturation is a good way to make grayscale images, or black and white visuals. The lightness corresponds to how the color is lighted, or the luminance of the color. Vertical distance is how this is represented. Full lightness is equal to white, no lightness is black, and the middle is the actual color hue. An alternate version of this is called HSV, hue, saturation, and value. This is another cylindrical coordinate representation of points in RGB. It is also known as HSB, where the B is for brightness. This is used many times in color pickers for creating visual assets. HSV and HSL are related, but the colors look slightly different. In relation to HSL, hue saturation is still the same, more or less. However, there are some subtle differences in the detail. The major difference with the concept involves lightness and value. Value corresponds to the amount of color that it is radiating. The value of 0 is no color or black. The value 1 is a fully bright color. The core difference is with HSL, when the lightness is full, that corresponds to white. But in this case, it corresponds to a fully saturated color. In one way, we can consider HSV values to represent the lower half of the cylinder described in HSL. For instance, we can think of a fully saturated green in HSL will be the same lightness value of 1/2 where it is in HSV. In computer graphics, 2D visual assets can be created using software which generates either raster graphics or vector graphics. Both of these concepts create images, but in slightly different ways. Raster graphics represent an image using a 2D matrix of picture elements called pixels. Raster, being German for grid, is a way of describing the 2D matrix. A bitmap is a data structure which holds bit information into a matrix. Commonly, it's represented by a 2D matrix. For our consideration, we can think of this as holding color data like RGBA hexadecimal values in each cell. When the image is drawn to the screen, then each bit of data is then mapped to a pixel or fragment on our screen. This is the classic way of storing 2D images in computers. File formats such as JPEG, PNG, and GIF, each of these contain bitmaps that are compressed using a variety of algorithms. There is also BMP, or the bitmap format, which is an uncompressed version of these. The three mentioned are important as they are common, but they do differ. For instance, PNGs contain RGBA data, while JPEGs only contain RGB. This means JPEGs shouldn't be used if we need transparencies. GIF also allows for RGBA, but also allows animated sequences through a variety of interchanging of the graphics. Game engines may process these differently, so it's important to look over the details of the engine in regards to these formats. Raster graphics are fast and commonly used in games as they do not need much processing to map the color data to our game worlds. However, there is a significant problem with raster graphics, which is scaling aliasing. If an image is scaled either up or down, then we have to interpret or lose information. This can leave a lot of visual artifacts and cause aliasing in the resulting image. To get around this, we look at the alternate vector graphics. Vector graphics represent an image using geometric shapes defined by mathematical functions on a Cartesian coordinate system. Points, vertices, lines, and polygons are the geometric primitives used to create vector graphics. Curves, or splines, are more complex geometries which interpolate a line between 2 points. Curves are a type of line which uses special control points to create arcs. These interpolative structures are what sets vector graphics apart from rasterized graphics. Some very common file formats for vector graphics include SVG, PDF, and AI. Vector graphics can be considered slower and typically needs to be rasterized before use in a game engine. However, there's no aliasing when they are scaled. An important concept in vector graphics is related to the more complex curve geometry. The points along the curve between 2 points must be interpolated. Control points are commonly used to guide the shape of the curve. In relation to this, a spline is a curve that is constructed using control points. Bezier curves is a way to interpolate these curves. Bezier splines are only one mathematical representation of curves. These were developed in the 1960s by Pierre Bezier. In this, it requires a set of 4 control points. The first and last points in blue are the anchors, and they represent the points at the beginning and the end of the curve. The other 2, the 2 in the middle in red, these determine the direction of the curve at those end points. This type of curve is commonly used in graphics programs. Catmull-Rom splines are another way to interpolate curves. These splines are also defined by a set of 4 control points. The big difference is that all 4 control points are actually on the curve. There are no extra points required except for the ones at the beginning and the end of the curve. This kind of spline is commonly used in pathfinding algorithms and smoothing motion between keyframe animations. A common 2D asset created by visual software are called sprites. A sprite is a 2D visual asset that is layered on top of a background image or other sprites. Sprites are smaller parts of an overall layered composition. Conceptually, they are small containers for color data representing one visual entity. They are considered to be an active visual entity, while as image files are similar but considered to be passive entities. To work with them, image files are processed by the game engine as a sprite. As mentioned, many sprites are layered to create the resulting image or frame of a scene. They do not overwrite the data of another sprite. The color data of one sprite does not replace the color data of another sprite. Instead, they float on top of each other. The term sprite was coined in the 1970s because they appeared to float like sprites over top of a background without overriding background data. To best understand, image files are converted into sprites. Passive visual entities to active visual entities. Sprites move while images do not. Organizing layered sprites is how we create common visual displays. Heads-up displays, player data, menus are just some major examples. 2D games are mostly about controlling and moving around sprites. Good user interface requires elements of visual design. We consider line, shape, colors, texture, etc. Sprites can either be a single image or animated. Sprite animation describes how the visual asset animates or moves locally over time. Global and local movements are two different concepts that occur frequently in game development. We can keep in mind this example. Global movement is the player moves from left to right in the game. Local movement is the player's walk animation plays. We keep in mind that the animation does not move the player. The game does. We fool the eye by playing an animated sequence while the player moves to give the illusion of walking. Animation is based on a sequence of frames. This is the same concept described in the game loop pattern as it is a still basic unit of time. Keyframes are frames that represent more important poses in the sequence. The frames in between these keyframes can be called tweens or in-betweens. Sprite sheets are a way that we can implement 2D character animation. One large image contains the entire animation sequence. These are then subdivided by smaller frames, sometimes called a fragment of a given fixed length and width. Animation occurs when each of the frames of the sprite sheet is followed in sequence. The previous image is replaced by the next one, which gives the illusion of a moving picture. We can think of this as being the same as flipbook animation. Animation playback can be played once, looped or played over and over again from the beginning, or ping-pong, where it plays forward, then in reversed, and then looped. Creating good animations require a little more in-depth and specializations in understanding visual design. For instance, the 12 principles of animation are important to understand as it helps us create more visually appealing movements. These were mentioned in the book Illusion of Life, Disney Animation, 1981, written by two former Disney animators, Ollie Johnston and Frank Thomas. The principles mention squash and stretch, anticipation, staging, straight ahead and pose to pose, follow through and overlapping action, slow in, slow out, arc, secondary action, timing, exaggeration, solid drawing, appeal. There is a lot to understanding this, but we will briefly go over each point. Squash and stretch is a technique used to give a sense of weight and flexibility to an object. This is not a rigid body, but it does retain its same volume. This is used in conjunction with slow in, slow out, which will be discussed later. Anticipation prepares the audience for an action. We can think of this as bend your knees before you jump. The bending of the knees leads the audience to the next action. Staging directs the audience's attention to what is important. This is a similar concept to the line. Straight ahead and pose to pose are drawing processes. They go about describing how to draw a sequence of images such as a walk cycle. In Straight Ahead, we only use key poses or key frames, and the animator draws each frame sequence representing the action. This is typically used in action sequences where details like exact proportions can be ignored without the viewer noticing. Pose to Pose uses many keyframes. This is a slower process, and it requires creating first a series of key frames and then creating the in-betweens carefully in between. This process is done for animations requiring more realism, or at least more attention to detail. We will see how pose-to-pose animation appears in other forms like 3D animation a little bit later. Follow-through and overlapping actions are related to creating more realistic physics. Center of mass and the principle of inertia play an important role here. Consider that a body in motion will stay in motion plays an important role here. If a character is running as fast as possible and comes to a sudden stop, then we would animate them continuing to move forward while attempting to stop, giving it a feel of weight. Also, different body parts move at different speeds, which should be considered when we're moving. The concept of drag relates to how a character may need a few frames to catch up before they start moving. Slow in and slow out is related to the acceleration of an object. Real-world objects accelerate based on forces. This is important to impart realism in our animations. More frames in the beginning and end, and fewer frames in the middle. This describes a way to implement the acceleration of animation. Arc describes how natural actions follow an arced trajectory. Using arcs create more fluid and natural-looking motions. Mechanical actions follow straight lines. This is a way to make an emotion appear unnatural or mechanical for lurching undead creatures or a robot, respectively. Providing a secondary action gives animation more realism. Walking while waving your hand or running while flailing your arms. Timing is the number of frames for this given action. The speed of the action is inverse proportional to the number of frames. Faster actions require less frames, while slower actions require more. Mood, emotion, reaction can be expressed based on the timing. Slow movements for dramatic effect and fast movements for excitement. Exaggeration helps to better display emotion visually. Perfect imitation of reality can appear static and dull. It can be argued that we tend to understand the emotions of caricatures more easily. A balanced approach involves staying true to reality but presenting it in a more extreme form. Solid drawing. Things have volume and weight. Understanding 3D shapes, balance, weight, light and shadow, and other visual design elements are important parts of this. Appeal refers to the character's charisma or their appeal. They should strive to be real and interesting. Game engines commonly process 2D assets as sprites. They uncompress the file based on its format. They rasterize the vector graphics. They set the animation frames for the sprite sheets. With all that being said, here's a few quick tips in order to create some visuals. Trust the color wheel, and remember that color mixing models. Use lower saturation on most colors. Highly saturated colors can be difficult to view for a long time. Lowering the saturation can lower eye strain. Neutrals help out other colors. Using neutrals in negative spaces and accent colors in positive spaces can help lead the eye and establish a line. Give the eye breaks. Don't make a scene too busy. In relation to that, use only a few fonts. Mixing a lot of fonts together can make a game hard to read. Create images using vector graphics, but then save them as a rasterized graphic format. For instance, save the SVG and the photo editor to edit later, but then export it as a PNG to use in the engine. Consider the principles of animation and be willing to reanimate. In this lecture, we've discussed visual assets and their various principles. We're going to be discussing more in the future, and until then, I'll see you next time.